Hello, and welcome to the AIRunway demo. Let's start from the beginning, installing AIRunway. So let's go and install our controller. Controller is the Kubernetes operator that will watch over model deployments and translate it over to the to each of the frameworks. So we are going ahead and installing our controller in here. The next step is to install our dashboard. For the dashboard, we can run it on Kubernetes, or we can run it locally with a single binary. While I'm installing it on here in Kubernetes, I want to show you how we can run this locally. So now I'm running it locally, and then let's go back and switch to our AIRunway website, and then let's go ahead and refresh. And then now we're connecting to our cluster, and then we are connected. Let's go to settings, and then runtimes. As you can see, we don't have any inference providers configured. So we need to connect one. Let's go ahead and jump in and connect Kaito. And then what we're installing is an adapter that will teach AIRunway on how to talk to Kaito, the inference provider. It tells it what engines it provides, what capabilities it has. You can think of it as like a plugin registration. It's how the platform stays extensible without any runtime specific code baked into the core. So let's go back and jump in. As you can see, Kaito is now available in the runtimes, but it is not installed. So we'll go ahead and install, but we'll fast forward since it will take some time. Welcome to AIRunway. Let's start with the model catalog. This is the first thing you see when you open AIRunway. Think of it as your app store for AI models. We have a curated set of popular models right here. Qwen, Phi, DeepSeek, Llama, each with a quick summary, how big it is, what engine it supports, and what is it good at, such as chat, text generation, multi-model, and so on. But the real magic is the GPU fit indicator on every card. It tells you instantly whether a model will actually run on your cluster, no guesswork, no trial and error. Before we deploy anything, let's do a quick setup. In settings, I'll start with integrations and connect our Hugging Face account. Because some of the most popular models are gated, meaning you need authorized to access them. I'll click connect with Hugging Face, standard OAuth flow. Once connected, two things can happen. I can now search and deploy gated models like Llama and Mistral, and the token gets stored as a Kubernetes secret so that the cluster can pull model weights during deployment. One login and it just works. While you're here, let me flip to the runtimes tab. There are inference frameworks that actually run your models under the hood. AIRunway supports multiple runtimes, and it is entirely extensible. You don't have to pick one and lock yourself in. Let me highlight two. Kaito, this is the Kubernetes AI toolchain operator, is the most flexible option. It supports both VLLM and Llama CPP, which means that it can run models on both GPUs and CPUs. It's the only runtime here that gives you CPU inference. Great for smaller models where you don't want to spin up expensive GPU nodes, especially for edge scenarios. And then here is NVIDIA Dynamo. This is the high performance choice. It supports VLLM, SGLang, Tensor RTLLM. What makes it special is its disaggregated serving. It can separate, prefill, and decode into independent worker flows, plus KV cache aware routing for smarter request distribution. And Dynamo has AI configurator that can automatically optimize your deployments, such as tensor parallelism, batch size, and whatnot, all tuned for your specific hardware. Both can be installed right here with one click. Back in the catalog. Now that we are logged in, let me show you the Hugging Face Hub tab. I can search the entire hub right from here. Because we are connected, it can show gated models too. Look at this large model. This is the MetaLlama 3.1405p instruct. See that it says won't fit. It needs more VRAM than what's available in our cluster. You can see exactly how much more you'd need. No surprises, no failed deployments. Now, if you compare to a smaller model, green bar, perfect fit, plenty of headroom in here. You know before you even click deploy that this one is good to go. Let's start simple. Let's search for a NVIDIA model in here. NVIDIA Nematron Nano Giga. We'll select the Nano one just so it's quicker. It's a compact model, and then let's click deploy. In this case, Kaito will be the only selected provider because we're going to run this off CPU. We also have the option to run off GPU through AI Kit. And then we select the quantization, and we can see our estimated cost for the CPU and then deploy model. Now our deployment is being created. And we'll give it a minute for it to get started. We have our gateway endpoint. Let's see if we can run inference here. And I'm going to prompt hello world. There we go. We have our response. This is great for development testing or scenarios where GPU capacity is expensive or constrained. The model runs on standard CPU nodes that are already in the cluster, quick, cheap, and no GPUs needed. Other extreme. We're going to go to Hugging Face Hub and then search for DeepSeek R1. And then you can see the DeepSeek R1 in here. This is 671 billion parameters. And then this is not going to fit in our single node, which has 8 H100s. So let's go into deploy. We're going to select Dynamo as runtime. And this is a good moment to talk about why. For large models with high traffic, runtimes like Dynamo and LLMD really shine because they support disaggregated serving. And what does that mean? Normally, inference has two phases, prefill and decode, and they run together on the same resource, which is fine for small workloads, but when traffic gets heavy or the model is very large, it becomes a bottleneck, and you can't optimize or scale each phase independently. Disaggregated serving separates prefill and decode into different resources, so each phase can be independently scaled and optimized, which improves GPU utilization, throughput, latency. And then for this demo, we'll use aggregated serving, but for production workloads with heavy traffic, disaggregated serving is where the runtimes really differentiate themselves. Now, I could configure all this manually, but now we have the AI configured with Dynamo, and then I can do this with one click and let it do its thing. It analyzes the model against our available GPU and specifically GPU type, and it comes with some recommendations like tensor parallelism and engine selection and more. And it'll optimize it for us. In this case, we're not going to go to the optimizations. I want to show you the specifics. So we're going to discard the recommendations. So let's go ahead and then add our configuration. We're going to deploy into the default namespace in this case. As you can see before, we didn't had the necessary GPUs in here, but because this model is so large, it's recommending 3 nodes with 8 GPUs each with 24 GPUs total. Because autoscaler is enabled for our case, even though we do not have the available nodes right now, autoscaler will enable it for us. Okay, let's go ahead and then configure our storage volume. So we store the data in a persistent volume. This is going to be backed by Azure Lustre, which is a high performance shared file system. The model gets cached there. And then, so on restarts or scale up, the new models don't have to download hundreds of gigabytes. In this case, like 650 gigabytes for DeepSeek R1. It's read-write mini, so all nodes can access it simultaneously. So let's configure. And I already created one, so we're going to use that one. Never make it read only. And you can also see the cost estimate of this in real time. This is coming from the Azure Cost Center. So obviously, this depends on your cloud provider. Cool. Let's go ahead and deploy. And then, because this model takes a while, we're going to fast forward to a deployed phase. Okay, here's our previous model, and then this is going to take some time to get to ready stage. It is now pending. DeepSeek R1 is running. Let's use it. First, let's look at our deployment page. On the deployment page, we can see our storage, and then our mounted disk and the path. And here is the gateway endpoint. AIRunway integrates with the API inference extension. In this case, we are using Istio, but it can be used with any supported provider. This gives us a single stable endpoint for all of our models. This uses the standard OpenAI compatible API. In this case, we are looking at the V1 chat completions API. Any tool or SDK that speaks OpenAI can talk to your models without any modifications. The gateway does body-based routing. So that means multiple models behind one URL. This even means multiple Kubernetes inference frameworks behind one URL. And then they're routed by the model field in the request body. In this case, this is the DeepSeek one. It's clean, simple, and scalable. Let's see if we can talk to our model. And then let's make sure we set it for DeepSeek. And then let's say hello. And then we have our chat back. So to recap, AIRunway gives you a unified provider-agnostic way to deploy ML models on Kubernetes. You browse a catalog, see instantly whether a model fits your hardware, pick a runtime, or let AIRunway choose it for you, configure it with a few clicks, or let AI configurator provide the optimal configuration for you and deploy. From a tiny model on CPU to a billions of parameters model with auto-scaling support and support for fast storage. You get a unified gateway endpoint, cost visibility, and one platform, multiple inference frameworks from CPU to multi-node GPU that is extensible.